Okay, welcome to 5.3 here, proving triangles congruent by the SAS theorem. Page 135 in your journal. Let's get rumbling. Congruent figures. This should be something that's familiar to you. We've already done this before. All corresponding sides and blanks are what? Remember, try to fill these in, pause. Even if when I don't say pause, try to pause it. Always try to answer yourself first rather than just copy things down. Don't worry if you make mistakes. Always test yourself. Always push yourself to get better. That's how you get better. Okay, that should be sides and angles. Okay, are congruent. Another way is, or they map to each other with rigid motions. So you can not twist it, you can turn it, you can rotate it, you can reflect it. And our rigid motions down here, we've mentioned these before, they maintain side and angle measures. We have three rigid motions: a translation, a blank, and a rotation. Use that pause button. Reflection was the one we were looking for there. So our SAS congruence theorem, that stands for side, angle, sides. If two sides and the included angle, I'll talk about the included angle in a moment, of one triangle. So we have two sides and an angle are congruent to two sides and the included angle. 1, 2, and there's our included angle of a second triangle. Then the two triangles are congruent. We don't have to do like last chapter and get every single part. We get these three parts congruent and we're golden. So included angle, that's where the two sides meet. So let's look at this first one over here a little bit. So they've got one side right there, one side right there. They meet at vertex A. That makes angle A or angle BAC or angle CAB your included angle. It's got to be where those two sides meet. So we have that side, we have that side. If you look at like this angle, yeah, it's attached to this side, but it's not attached to that side. It's not going to the vertex. It's got to go to the vertex, not just to some random point on the side. That's not helping us over there. Okay, included angles. They connect the two sides. So if you notice, you can go without picking up a pen. Another way to think of this, I'm going side. I hit the angle and write up the other side. Okay? Side, side. This is not like this one. So this one I can go side, angle. I got to go through another side before I get to the side. That one's not working. I should have tried that in a different color. Side, I'm at the angle. I got to go up another side before I get to that other side. That doesn't work. It doesn't work the other way either. Angle, side, side. That didn't work. Side, skip a side, angle, side. That doesn't work. Okay. Included, formed by the two angles. So I want to get the included angle here for RS and ST. So here's RS, here's ST. That's going to be angle S, or you could say angle RST. You could say angle TSR. But notice S is still your vertex in those. It's angle S. You could have also got it from this over here, just like here. Oh, T's in both of these. That's got to be the vertex. So let's go check that out. I trace those out. Here's TR. Here's ST. You can see those converging at that vertex of T. That makes T our included angle. This is a big thing, guys. Mark your congruencies on your diagrams. marking congruencies. That's that. Always do that. That's how most people mess up these proofs. They're trying to keep it in their head. Don't do that. Mark your diagrams. You'll see me mark them all the time. Wow, that's it for the notes. We're into practice. Let's rumble. Okay. Proof. Think on your diagram first, then document steps. It's actually going to be harder to read this. You think on the diagram, you'll get information that should match up with these usually. I'm not even going to look at these to get started. Okay, so triangle ABD. Let's do it this way. Triangle ABD. That's this one. Triangle CBD. That's this one. Those are the two triangles we're looking at. We're given BD is perpendicular to AC. We've got that marked. We're given AD is congruent to CD. We have that marked. Okay. I'm also noticing a reflexive property in here. I also see my perpendicular lines marked here. That means I actually have congruent angles because that's also a right angle. So that gives me congruent angles. Oh, I have three parts of information. 1, 2, 3. 1, 2, 3. Those are lined up. I got these sides, then I have an angle, then I have the sides. That looks like an SAS proof to me. Okay, so I've thought it out on the diagram. Now we're going to come and look at these. You can write these out. Please never get number 1 wrong. That's always given. That's where we start with, just that information. I put it on there to get a free question right. Okay. Perpendicular lines form right angles. Perpendicular lines form congruent right angles. Angle BDA, that's this angle. One of them I've got marked. We said that was congruent to this angle there. Okay, so that's BDC. Again, I should be mentioning, pause this, try to get these answers in here before I do. I got marked diagram written here. It should be marked on diagram because we looked at this. Why is BD congruent to BD? What's our reason? Again, use that pause button if you haven't already. That is our reflexive property. That's LEXIVE. Sorry about that. And then I already mentioned we got our side angle side. Again, just let's look at that side angle side bit here. Here's our side. Vertex angle straight into the other side. Side. Vertex of the angle, that's congruent right into the other side. We've set that up. Now this one, I'm going to let you work this one a little bit more. We should have checked this up here. I mentioned given we had BDC, there's our BDC, and then we had a reflexive, so these other answers go down here. Take a look at what you're going at over here. So think about this. Okay, this is a side. This is a side. We have those marked over here. Okay? This tells us we need our included angle. Now, a lot of times you don't have to force that. That's just going to be what comes out. Let's look at what we have here for triangles. J and K. Here's J and K. M and L. There's M and L. So those are the two triangles we're looking at there. I see some vertical angles in there. There's that step for that one right there. Very poorly written. Sorry about that. I should rewrite this someday and make it legible. But complete that. You got some scrambled answers to choose from at the top. This one we already... No. 4 things. I got 3 answers here. Just noticing that shouldn't be up there. We already have that in down here. Okay, trying to prove this congruent over here. So this time we've got these angles marked congruent. This is just different ways of naming the triangles. Use the given information to name 2 triangles that are congruent. Explain your reasoning. We're going to use all radii of a circle are congruent. That's going to give us all these segments congruent. Now you have your SAS in there. Okay. Regular hexagon. I forget how much we've talked about this. Regular means all sides and triangles are congruent. Now again, I can get other triangles incongruent over here, but we know all their angles are congruent. So that makes this angle, because that's this angle here. This angle is this one there. They have to be congruent. All these sides are congruent. That would be these sides right here. All theirs are congruent. Notice you've got your SAS proof in there. I could get triangle AFC and DBE congruent. That's going to be a little bit more work in there. I mentioned redrawing the diagrams to make it clearer. That's what we did over here. I'd already had that done ahead of time. Sometimes you take the diagrams out of the big draw diagram. It makes it a little easier to see. This one, our old quilt here, as I mentioned, always mark your diagram. We know PS is Q parallel to QR. I've got that marked over here. We know PS is congruent to QR. I've got that marked over here. Parallel and congruent aren't always together. You got to have those statements. We got those are congruent. Parallel and congruent. Okay. So that's our givens. So that's what would be going right in here for your givens, is just take these, put them in. Okay. Those go over your given. You can put 2 on the same line. You can put them down twice if you want. You've got a reflexive property in here. Okay. I should look at this. We're trying to look at triangle PQR. I should have looked at this ahead of time. PQR right there. And RSP right there. Hey, I got a reflexive property in there, I see. Right there, that segment's in both of the triangles. I got that congruent. So there's my reflexive property. Get that statement in there. Get those givens in there. Alternate interior angle theorem. I should have had 2 slashes there because I've already got the 1 slash right there. You can use that for right here. There's your Z. That's going to get your included angles congruent. Name those angles. Put them in there. I'm just about out of time. And then you got to go this one. So this one is pretty easy. This one's just coming down. That's always our last step. That's easy to write out. The reason we have to come up with, that's the only reason we got side angle side. So that's it for this section. I'm going to end this a few seconds early.